All right, so today we're going to be talking about solving three-dimensional systems of equations with elimination. So using elimination is something you should already know from solving two-dimensional systems of equations, but we're going to be doing three-dimensional systems which will look something like this. The goal here is to take something that has three equations and three variables and transform it into something that has two equations with two variables by eliminating the same variable twice, and then doing what we already know how to do, taking a system with two equations and two variables and transforming it into one equation with one variable so that we can solve for that variable. And we just simply work backwards and input the variables that we know back into the equations that the variables that we need to find. So one of the things we want to do first is look at these three equations and just try to make a decision on what is going to be the easiest variable to eliminate twice, either the x's, the y's, or the z's. And it looks to me like the z's are going to be the easiest to eliminate because I won't have to multiply the equations by anything. If I just call this equation number 1 and this equation number 2 and this equation number 3, I can first start by taking equation 1 plus equation number 2 and just adding them together, and I will eliminate a z. So 2x plus x is 3x, negative y plus 3y is plus 2y, and then a z plus a negative z, those are eliminated, and that's going to equal 4 plus 11, which is 15. So then I can do the same thing with equation 1 and equation 3. If I just add those equations together, 2x plus 4x will give me 6x. A negative y and a positive y, well, those are eliminated. That's kind of a bonus here because the z's are also eliminated, and then 4 plus 14 just gives me 18. And so now I have a system of two equations with two variables, and it's kind of nice because I also have one equation with one variable. If I take the 6x equals 18, that's one equation with one variable, and I can use that to solve for x. If I just divide both sides by 6, I'll have that x is 3. And so then I can plug 3 back into this equation here to figure out what y is. I know that 3 times x, well, 3 times 3 is 9, plus 2y is equal to 15. So if I subtract 9 from both sides, I'll have 2y is equal to 6. And if I divide both sides by 2, then y is equal to 3. So, but then I also need to figure out what z is. So if I take the very top equation, I know that 2 times x, well, that's 2 times 3 is 6, minus y, well, that's minus 3, plus z is equal to 4. And so 6 minus 3 is 3, plus z equals 4. If I subtract 3 from both sides, I'll get that z is equal to 1. And my solution is that x is 3, y is 3, and z is 1. And if I plug those three numbers in for x, y, and z into all three of those equations, I should get 4, 11, and 14, respectively. Let's try this with a different system. So again, here, one of the things we're going to try to do is eliminate the same variable twice. So I want to look at this and see, is it going to be easiest to eliminate the x's, to eliminate the y's, or to eliminate the z's? And it looks like the y's, to me, are going to be the easiest to eliminate. If I call these equations 1, 2, and 3, I could just add 1 plus 2 together, and I will eliminate the y's. So I will have the 2x plus 3x is 5x. Y plus negative y is nothing. They're eliminated. Negative z plus 2z is plus z. And 5 and negative 1 is 4. Well, then I am going to use equation 1 and equation 3 and add those two equations together. So I'll have 2x plus x is 3x. And then y plus negative y, they're eliminated. A negative z and a negative z is a negative 2z. And then a 5 plus 0 is 5. And so now I have two equations with two variables. And now I'd have to figure out, is it going to be easiest to eliminate the x's or the z's? And I think if I take this top equation here and multiply it times 2, I will have 10x, and then 2z, and then 4 times 2 is 8. So now if I add these two equations here together, I will have 13x. The z's will be eliminated, and 5 plus 8 is 13. So if I divide both sides by 13, I'll have that x is 1. So then I'm going to go back to one of these two equations. I'm going to use the top one. 5 times x, well, that's 5 times 1, which is 5, plus z equals 4. And if I subtract 5 from both sides, I'll have that z is equal to -1. So then I'm going to go back to one of my original equations, and I'm going to use this top equation here. I'll have 2 times x, well, that's 2 times 1, which is 2, plus y, minus z, well, that's minus a -1, which is plus 1, equals 5. And 2 plus 1, I can put those two together, that's 3. So y plus 3 equals 5, and if I subtract 3 from both sides, y is 2. And so it looks like my solution is when x is 1, and y is 2, and z is -1. And that will be my system here for example number 2. So let's try this again with a story problem. So you've done this before with two equations and two variables, and this is really not much different. We're just adding another variable and another equation. And so at McBeef's, you can buy 2 orders of fries, 2 hamburgers, and 3 sodas for $24, or 4 orders of fries, 2 hamburgers, and 1 soda for $14, and 3 orders of fries, 1 hamburger, and 2 sodas for $11.50. So how much is each item by itself? So what I'm going to do is let the fries be my x's, the hamburgers will be my y's, and the sodas will be my z's. And in the first situation, if I have 2 orders of fries, that's 2 x's, plus I will get 5 hamburgers, which is 5 y's, plus 3 sodas, that's 3 z's, for a total of $24. The second situation, I will get 4 orders of fries, that's 4 x's, plus 2 hamburgers, that's 2 y's, plus 1 soda, that's 1 z, equals $14. And then in my last situation, if I order 3 orders of fries, that's 3 x's, 1 hamburger, so that's 1 y, and 2 sodas, that's 2 z's, 2 z's for $11.50. So here is my system that I came up with from the story problem. And so just like before, I want to try to figure out what is it going to be the easiest to eliminate. There's really no wrong answer. You can eliminate either the x's, the y's, or the z's. I am going to go and look to see if I can eliminate the z's though first. I'm going to take the top 2 equations, and I'm just going to rewrite the top equation, which is 2x plus 5y plus 3z equals 24. And I'm going to take the second equation here and multiply it times -3. So I will have a -12x, and then a -6y from the 2y, then -3z from the z, and then 14 times -3 is -42. The reason I did those is because now I can eliminate the z's here by adding these two equations together. I will have a -10x, 5y minus 6y is a -y, the z's are eliminated, and 24 minus 42 is -18. And there's my first equation with 2 variables that are x's and y's. So I'm going to do that again. I'm going to try to eliminate a z again using my first 3 equations. And so what I'm going to do this time is take the third equation, the 3x here, and I'm going to copy that down. I'll have 3x plus y plus 2z equals $11.50. And if I take the second equation and multiply it times -2, I'll have a -8x, and then minus a 4y, and then minus a 2z, and 14 times -2 is -28. So now if I add these equations, my z's are going to be eliminated again. I'll have a -5x minus a 3y, and 1150 minus 28, I believe, is negative $16.50. So there's my second equation with the same two variables. And so now I'm going to use these two equations and see if I can either eliminate the x's or the y's. And actually, I think the easiest way to probably do this would be to take this equation here and multiply it times negative 2, because then I'm going to have a 10x plus a 6y, and 1650 times negative 2 is going to be 33. So when I add these equations together, my x's are eliminated, and I'll have negative y plus 6y is 5y, and negative 18 plus 33 is 15. So if I divide both sides by 5, I'll have that y is 3. That means my hamburgers cost a total of $3 at McBeef's. But then I still need to figure out how much are the fries and how much are the sodas. And so I'm going to go back to one of my original two equations, and let's say I pick this equation right here, and I know that the x is 3, so negative 10 times 3, well, that's negative 30, minus y equals negative 18. I'm sorry, I need to plug in the 3 for the y. So I'll have a negative 10x minus y, which is minus 3, equals negative 18. And if I were to add 3 to both sides, I'd have negative 10x is equal to negative 15. If I divide by negative 10, I'm going to have x is 1.5. 1.5 here. 1.5, now I'll get it. Okay, so that means that the fries are $1.50. Then I have one more that I need to find, and that is the sodas. And so now I need to figure out what z is. And so I'm going to use this first equation. I have two x's. Well, that's 2 times $1.50, which is 3. Then I have 5 y's. 5 times 3, that's 15. Plus 3z, and I don't know what z is yet, equals 24. But 3 plus 15 is 18, plus 3z equals 24. And if I divide both sides, or if I subtract 18 from both sides, I'll have 3z is equal to 6. And if I divide by 2, then divide by 3, then z is 2. Which means that a soda must cost $2. And there I have the answer to all 3 questions. I know exactly what each item cost because I can do 3-dimensional systems of equations using elimination. Good luck on your homework, and we will see you tomorrow.